This video is in preparation for sections 2.4 and 2.5. We're going to be practicing with simplifying negatives to exponents and identifying some core functions as part of this course. So starting off with simplifying some negative inputs. This gets really tricky sometimes. Really, it's a common mistake that I see sometimes where the negative, if you're plugging in negative x into a function, that negative does not end up inside the parentheses when it really needs to. So something like negative x squared, well, that's really the same thing as doing negative 1 squared times x squared, which we don't often write it out that way, but you can see then that you're breaking off the negative component, which also gets squared to positive 1. So this just simplifies to x squared. Now, if we think about the next one, we would have negative 1 cubed x cubed. Well, negative 1 cubed is negative 1 times negative 1 times negative 1. That gives us negative 1 overall. So we're left with negative x cubed. In general, when your exponent on the negative is even, overall it becomes positive. And when your exponent is odd, overall it becomes negative. Okay, so let's write that down. Even exponent implies positive, odd exponent implies negative. That's what we saw happen with negative x squared and then negative x cubed. Now, what happens if we have an extra negative outside the parentheses? Well, we know if we leave that negative, and we know negative x squared is just x squared. Now we have a negative outside the parentheses. That is not getting squared. It's just hanging out front. So this becomes negative x squared. For the next one, we have a negative x to the fifth. That negative x to the fifth, with the 5 being odd, means that negative stays. So we end up with the negative out front and a negative x to the fifth like this. But a negative times a negative becomes a positive, and we're left with just x to the fifth. Now we see it sometimes when it's part of a polynomial, not just standalone terms. So if we look at 3 times negative x squared, well, that's just 3x squared. We know the negative is being squared away. 2 is an even exponent. And then we have plus 5 times negative x. Well, that negative x has an x to the 1. Really, 1 is in the exponent. That's odd, so that negative is staying. And the negative really ends up going in front of the 5, and we have a minus 5x. So it just takes a little bit of practice, but this is going to come up a lot this week. Now we're looking at finding negative x and simplifying completely. So it's really f of negative x. Well, here, f of negative x is negative x squared, negative x squared plus 3. We already saw that simplifies to x squared plus 3. So the negative essentially fell away. Now if we look at f of negative x, for this next one, it's negative x cubed minus negative x to the first. Well, that's just a minus x cubed. Then I have a minus negative x, which of course is plus x. Now for the last one, we look at f of negative x. And we have 2 times negative x squared minus 5 times negative x plus 1. And if we simplify that, we have 2x squared plus 5x, right? Minus 5 times a minus x. And then we have a plus 1. And that's it. Whenever you plug in a negative x, just make sure it goes in parentheses and that you handle all exponents appropriately. And then it's just some standard simplification rules. The third example on here, in a sense, are just kind of collecting some of these parent or core functions that we're going to be working with. See, we pick functions and then we like to identify their graphs, and we build other graphs based off of these core functions. So of course you see y equals x, the linear function, come up a lot. We have y equals x squared, y equals x cubed, which is an S-shaped version. We have y equals absolute value of x, y equals square root of x, y equals 1 over x. And these are just some of the basic ones I could think of. You'll see an even longer list in lecture. You want to get really comfortable at recognizing kind of the general shape of these types of functions. So there's some practice here on the worksheet, and then actually matching some core functions to their graphs, which you can use a calculator to do if you need to. But please give this a practice, and as always, reach out if you have any questions.